Carbon.
Carbon. It's in all living things, including you and me, but most importantly for this conversation, it's in trees.
So it's a critical moment in Colorado's forests. Years of persistent drought have stressed forests all across the state.
Process that uses radio frequency technology.
Bark of the Douglas fir is dark brown to gray.
That relationship that we as people have with the natural world.
We're sitting around here where there's a lot of dead and dying timber.
We want interns to feel like they have a really well-rounded experience.
Think about it that you're investing in the future here, not just for yourself, but for everyone.
Welcome to Forest FM, the official podcast of the Colorado State Forest Service at Colorado State University. My name is Matt McCombs, State Forester and Director of the Colorado State Forest Service. Today, we're looking at carbon in Colorado's forests. As trees grow, they take carbon dioxide out of the atmosphere and store it in their tissues, roots, and surrounding soil. The state of Colorado fundamentally embraces the idea that natural and working lands can play an active part in mitigating climate change. It's why we and our partners are pursuing climate-smart management of forests, rangelands, and wetlands all across the state, prioritizing things like carbon sequestration to reduce greenhouse gas emissions as we go. Today, we'll hear from experts on the status of forest carbon in Colorado.
My name is Ashley Woolman. I work for the Colorado State Forest Service within our Science and Data Division as the Forest Carbon Specialist.
Tony Vorster, I'm a research scientist at Colorado State University's Natural Resource Ecology Lab.
More research is needed to help us understand the role that these lands can play both for climate mitigation and in reaching Colorado's bold climate goals. To support this, House Bill 22-1012, called the Wildfire Mitigation and Recovery Act, was passed in 2022. It tasked the Colorado State Forest Service with developing a publicly accessible statewide carbon accounting framework to help us understand where we are and where we should be going. This includes how much carbon is stored in our forests and how these amounts change over time, broken down by county, forest type, and wood products.
Thanks for joining us today. My name is Phil Peterson. I'm a forestry communications specialist with the Colorado State Forest Service. Before we dive into the specifics, let's explore some key concepts when discussing forest carbon. And this will help us put the bigger pieces together when we start to look across the state as a whole.
A key thing to understand when we're talking about forest carbon is that half of wood is carbon. So if you're looking at a tree or holding a piece of firewood in your hand, half of that weight that you're feeling is carbon. When we talk about forest carbon, we talk about what we call pools of carbon. So we talk about the above ground pool as an example. That's all of the carbon that is in standing live trees, standing dead trees, the downed material on the forest floor, the shrubs. You can also look at a below ground pool that is the roots of those trees. It's the carbon in the soils. But you can also talk about live pools versus dead pools. How much of this carbon is in living trees that are still adding carbon, and how much of it is in dead trees that are in the forest standing holding carbon.
So it's important to understand that forest carbon is constantly changing due to a number of different factors. And the first thing I like to think about is it begins with growth. So carbon comes into a forest through photosynthesis, and as trees grow, they absorb CO2 or carbon dioxide from the air and store it in their wood, their leaves, and their roots, like above ground or below ground pools, as Tony mentioned. When trees die, whether it's from age, competition, disturbance like a wildfire or insects and disease, carbon gets released back into the atmosphere as trees decompose. But it's not an immediate release where all the carbon is suddenly just gone. Microorganisms and bugs and fungi that are in all these forests will eat away at the dead material, and this releases some of the carbon back to the atmosphere. But all of this is pretty slow going, and dead trees can continue to store carbon for a pretty long time. The cycle wouldn't be complete if we didn't consider how humans are also part of this forest carbon cycle, particularly when we cut trees down and we use them for lumber or other products like furniture or even things like biochar. And when we use these products, we actually extend the life of the stored carbon that's in that material. So instead of releasing CO2 through decomposition in the forest, the carbon stays locked in the wood product for the duration of its lifespan until it's discarded. So things like a campfire where you're burning wood, for example, that carbon can be released back into the atmosphere, but other things like furniture, that can take more time for that to decompose.
When we talk about forest carbon, there's a few other terms that are helpful to understand. And two of those are what we call carbon stocks and carbon fluxes. And the stocks are like a snapshot in time. They're what's in the forest right now. The flux is how that's changing over time. And you can almost think about it like a bank account. If the forests are the bank, the balance in the account is the stocks. That's how much is there right now. The fluxes are those debits and withdrawals, the changes in that account. And you can look at the balance of what's coming in and what's coming out. And forests that have more carbon coming in through growth than they have leaving through decomposition or burning are sinks of carbon. They're capturing more carbon than they're releasing. Opposite of that is having a forest that's a source of carbon. And in those forests, more carbon is leaving the forest than is coming into it. When we talk about Colorado's forests, we'll talk about areas that are sinks of carbon, areas that are sources of carbon.
Ashley and Tony live in different parts of the state, and they see different forest types and conditions on a daily basis. As a result, the story of carbon is unique between their two areas.
So I live and work outside of Gunnison, which is in the southwestern part of the state. And I spend a lot of time on our public lands up in the high country. It's a lot of subalpine forests dominated by Engelmann spruce and subalpine fir trees. These trees are pretty big. They're large and old, and they store a lot of carbon. They're typically thought of as a carbon sink. They hold some of the highest carbon stocks in the state. However, in the 2010s, we saw a big increase in insect and disease outbreaks across this area. So a lot of spruce and pine beetle and now spruce budworm has come into a lot of these stands. And so there's been a shift of more dead trees on the landscape. The carbon is still being stored there. There's still a lot of carbon in the different above ground and below ground pools. It's just moving from live material to dead material now. And so over time, this carbon gets released back into the atmosphere, or we can salvage these trees and we can harvest them and make different products out of them, and continuing to store carbon as various wood products. So now with insect and disease outbreaks, they might be a source of carbon, but one day with regeneration and new trees establishing on the landscapes, they can return to a carbon sink again one day. And it's this constant cycle back and forth.
I live along the Front Range, and when I head out into the forest here, I often find myself in a burn forest. We might see two different types of fire. We might see a forest that's been burned by a low severity fire, or where it only killed some trees and other trees survived. And in those areas, the impact to forest carbon from that fire might be relatively minor. It's only killing some of the small trees with a little bit of carbon, leaving those big trees surviving that are storing a lot of carbon. So those forests would recover to be a sink of carbon again much quicker than what might happen in a high severity fire, where the fire comes through and might kill every tree in the area. In those patches of high severity fire, we have complete tree mortality. The impacts to the forest carbon there are much more severe. A lot of the carbon is still there in those dead trees. Some of it was released by the fire itself when it burned some of that material. And importantly, that forest just isn't going to be adding new carbon in the subsequent years as fast, because those trees are dead, and there might not be many new trees coming in because there might not be a seed source in that area to spur on that next generation of trees.
So now we have some key terms in mind, and we can explore what it actually means to measure forest carbon and help understand carbon across Colorado's forests over time.
Let's start with thinking about a single tree. How would you go about estimating how much carbon is in, one tree in your backyard? The basic method for this is you measure the diameter of that tree, and then you plug it into an equation that tells you for a tree of that diameter and that species, it has about this much carbon. It's an estimate, so it's not perfect, but it does a pretty good job of generally telling us how much carbon on average is in a tree of that species and size. So that's really the basis. That tells you at one point in time, we have this much carbon in this tree. Going back to our bank account analogy, right, that's the current balance, that's like current stock in that one tree. If we want to look at the flux or the change in that carbon, we can measure that tree, say, 10 years apart, and that tree will have changed its diameter as it has grown, and that is what tells us the flux of that tree, or how much carbon has come into the system. What we do then is we measure not just one tree, but a bunch of trees in one area to get the amount of carbon in a specific area, or what we call a plot. Now we have the amount of carbon in that plot, and then we do a bunch of those plots all over the state, and that's the foundation for how we estimate how much carbon is in our forest. We make sure those plots are in all sorts of different forest types, that they're in all the different counties, that they represent fire and bark beetle and harvested areas and all these different circumstances.
So we used a plot network called FIA, or Forest Inventory and Analysis, which is this nationwide program. It's run by the U.S. Forest Service, and it has these plots that Tony's talking about spread out all across the country, and it's on all different types of ownership, so private land, national forest land, national parks, and it's commonly referred to as the forest census. In Colorado, plots are measured every 10 years, and CSFS has this unique partnership with FIA to measure plots all across Colorado. So plots are measured every year. We have field crews that start to go out in the spring and work all summer and fall, and they are on the ground at these various plots, tracking and recording data about the individual trees, the mortality, if there's removals with harvests, what kind of species, how tall the trees are. And it all goes into this public database that's available online for anyone to look at and use the data. And it's just this incredible resource for answering questions related to forests at a large landscape level scale.
So that network of FIA plots tells us how much carbon is in the forest ecosystem itself, but that's only part of the picture. We also want to understand what's going on with that carbon that was removed from the forest through a timber harvest. So we look at the harvested wood products carbon. We use surveys of mills to understand how much wood is coming out of the forest and going into the mills, and what sort of products those mills are making, because different products store the carbon for different amounts of time, and we need to account for that. Like Ashley mentioned earlier, you might have a 2x4 in your house that comes out of the mill and stays in your house for decades and decades and decades. That continues to be stored. We don't want to count that as carbon that's emitted to the atmosphere. Contrast that with firewood that's burned, a year later, and that carbon is emitted to the atmosphere. We want to account for those different outcomes of wood that's harvested from the forest. We track the carbon in these wood products as it decomposes, it's recycled, or it moves to the landfill.
So now that we've kind of talked about these two different ways to track and monitor forest carbon, whether it's in a forest or in a product, that brings us to the point of talking about the report that we've been working on for the last couple of years to provide an in-depth inventory of the state's forest carbon. So we were able to track carbon in forest ecosystems using FIA plots, this network of plots all across Colorado, and we tracked harvested wood products using the different mill surveys that Tony talked about. We used plots that were measured between 2002 and 2019, and we used mill surveys from 1954 to 2019. And it was incredible to go back to the 50s with the best available data that is publicly accessible, and same for FIA data. So a couple of things of what this report is and what it is not. What it is, it's an inventory to quantify how much carbon is in our forests and how this has changed over the years and what is driving these changes. It's a framework that can be repeated every several years as conditions shift and change on the forest and as new data becomes available. And it's a source of data for the state by county, forest type, and ownership to start to look at these trends and changes on a more detailed level. It's not a plan for climate responses or for policy suggestions. It's not a prescriptive management tool for individual projects on the landscape. It's not a report card of whether this carbon is good or bad. But some of the things that this inventory can do is it can inform some of these things. So it can inform projects, it can inform policy at the state level, and it can inform individual county climate action plans. At the root of it, this inventory is meant to inform state level and landscape regional level carbon dynamics.
So we've just laid out what's involved in looking at carbon in Colorado's forests and how we measure the carbon in both ecosystems and harvested wood products. What we have now is a framework to be able to analyze these conditions over time, and we can explore what was revealed from this initial inventory and what that information shows us.
One big thing that jumped out is that the amount of forest carbon still in the ecosystem really dominates Colorado's forest carbon budget compared to the amount in the harvested wood products. Over 99% of the forest carbon is in the forest, and less than 1% is in the harvested wood products. So I'll just take a minute to talk a little bit about the harvested wood products. It was interesting to see in those surveys of the mills, from the 50s to now, those trends in harvest over that time. Harvests were really highest before 1979 and then dropped by roughly half after that point. Another thing that jumps out is just how much the National Forest System accounts for. Most of the timber products in Colorado come from National Forest System lands, but we do see private lands become a more important or a larger contributor to the harvested wood products starting about the 1990s. It's not all that surprising that the harvested wood products account for much less carbon than the forest ecosystem. We don't have a really large forest products industry in Colorado like might be the case in the Pacific Northwest. But it did also highlight the importance of that harvested wood products industry. We're going to need to continue to manage our forests for things like reducing wildfire fuels or to clear areas around our homes and things. And really, you can not use that material and it can be released to the atmosphere rather quickly. Or when you have an industry in place, they can use that material, put it into longer-lived wood products that continue to store that carbon. So now let's look at the forest ecosystem carbon that does dominate the state's forest carbon. We found there to be about 1,500 teragrams of carbon in our state's forests. About 60% of that is in the soil. About 20% of that is in the above-ground portion of living trees. To put that number in perspective, we can compare it to some other states in the western U.S. And if we compare it to Oregon, we have about half the carbon of Oregon. And to compare it to some states closer by, Utah has 660 teragrams compared to our 1,500. And New Mexico has 700 teragrams of carbon in their forest. So we have about double the amount of forest carbon as the state of New Mexico. When we look across different types of forest in our state, it was interesting to see it's our highest elevation forest and our lowest elevation forest that have the most carbon. Our spruce fir forests have about 30% of our carbon, and pinyon juniper forests have about 20% of our state's forest carbon. So that's the stocks, that's the snapshot of what's in our forest right now.
But these stocks have also been changing over the last 20 years.
Overall, we found Colorado's forests to be a net source of carbon at 0.9 teragrams of carbon per year.
That means our forests are emitting more carbon than we're sequestering.
And when we compare it to the amount of carbon stored in our landscapes, it's 0.06%.
That's just a fraction of 1%
of the carbon stock that is being lost on average each year. So we're just a slight net source of carbon.
In other words, what's going out and what's coming in, it's almost equal. We're just losing slightly more than what we're taking in.
So a key result at the state level was that the growth is not keeping up with the overall mortality of Colorado's forests. So, and again, thinking back about the carbon cycle and the transfer of carbon, a lot of this carbon was transferred from live material or live biomass to dead material and dead biomass. Live above ground pools had the greatest loss in carbon, mostly because we saw an increase in dead above ground and below ground pools.
So we're seeing a transfer of carbon that was stored in live material being now stored in dead material.
That carbon is still there, it's just in the dead material. However, our forests are still pulling in CO2 and storing carbon at the same time. It's just in these dead trees, these dead snags, the down woody material, and dead roots that are across our landscapes.
A lot of this change is attributed to disturbances.
I talked earlier about the different insects and disease we're seeing in Gunnison County, and then Tony talked about the wildfire impacts that he's seeing along the Front Range and Larimer County. We did find that insects and disease impacted more area than all other disturbances combined, and this accounted for more than 60% of the carbon loss. There was this large impact of insects and diseases, a lot of bark beetles, that accounted for this loss of carbon and this release from dead carbon pools into the atmosphere.
Although Colorado might be a slight source of carbon rather than a sink, it's not the same across every part of the state. When you isolate individual counties, regions, or forest types, there are many areas where Colorado's forests are actually carbon sinks instead of sources.
And so, for example, Gunnison County, where I live, has the highest carbon stock in the state, and it's also a carbon sink. So these various forests across Gunnison County, although there's still mortality, although there's still disturbances, they are pulling in more carbon than they are releasing. And on the other hand, Larimer County along the Front Range is one of the highest carbon stocks in the state, yet it's a carbon source. It's still sequestering carbon every day, but there's more carbon released than what is being sequestered and pulled in from the atmosphere. And there's different factors like climate, with how much precipitation these areas get, what the temperatures are like, and these different types of disturbances, whether it's a fire or bark beetles, and how these different factors interact on our landscape goes into how these forest carbon dynamics are shaped and how much carbon is being sequestered versus how much is being released.
The amount of carbon released from Colorado's forests will continue to increase as more disturbances are accounted for with future data sets.
Because this report only goes up to 2019, we were not able to assess the recent fires that occurred in the 2020 fire season. And so as future reports come out and assess additional changes on the landscape, these newer fires from 2020 and 2021 will start to get incorporated, but it can take time for these changes to be included within future inventories.
But in the meantime, new trees continue to grow, take in, and store carbon. This carbon inventory gives us a detailed look at carbon in Colorado, and it's a solid foundation to build from for future research. But carbon is a complex topic, and conversations around forest carbon need to be put in context of other factors that are shaping our forests.
Understanding state-level carbon trends is helpful, but it doesn't tell us about what's happening or what the impacts of specific forest management projects are, and that's an area of active research where we still need to learn a lot. Another thing to keep in mind is that these carbon inventories are really sensitive to the time period looked at. So we found that our forests are releasing carbon. That's the trend since the early 2000s. But if we just change our baseline, if we look to a different set of time, we might find that our forests are sequestering more carbon, or adding carbon to it. So for example, if we compared our current forest carbon to the carbon of 100 years ago in Colorado, we would probably find the opposite, that our forests are a sink of carbon. But we need to emphasize that carbon is just one aspect of the forest. It can just be one management objective that has to be balanced with many others. Forest managers are also thinking about wildlife. They're thinking about wildfire risk. They're thinking about economics. They're thinking about recreation. So carbon isn't the only thing that matters in these forests. And many of our actions, they're going to reduce the amount of carbon in the forest, and that's okay. You know, it's being balanced amongst all these other priorities. You know, we have to think about, do we care about just the overall amount of carbon in our forest or the quality of that carbon? So we can have a forest that is loaded with carbon, but it might burn really severely in a fire. It might be lost easily. In contrast, we remove some of the carbon from that forest, so we reduce the stocks. But maybe when a fire comes through, it doesn't kill all the trees, and it's a more resilient carbon stock. Those are the sorts of conversations that forest managers are having, that they're thinking about. And, of course, climate change looms over all of this. Our forests are changing and our climate's changing. Our responses to wildfires and the impacts of drought are going to change these carbon stocks, and that has to be kept in mind throughout all this.
This carbon accounting framework is coming soon, and you'll be able to explore all of the pieces we've talked about today in as much detail as you'd like.
It will be available on the Colorado State Forest Service's website, and you can download the report and really dive into different regions and counties and forest types and ownerships and what is interesting to you. Aside from the report itself, we will also be releasing various summaries of findings. There'll be some data exploration tools. The website itself will host all of this information.
With the release of this report, our Science and Data Division is also diving into the Carbon Co-Benefits Framework.
And it will tie our Colorado State Forest Service Forest Action Plan that came out in 2020 and the different approaches and strategies we have for managing Colorado's forests to projects that can increase carbon sequestration across Colorado.
We'll also be releasing the biomass assessment on top of this.
That takes a deeper dive of looking at harvested wood products in the state and finding new opportunities for biomass utilization and ways to expand our forest products industry across the state. There's a lot of ties to the carbon report and the biomass assessment.
An undertaking like this report wouldn't be possible without collaborative effort. We'd like to take a moment to thank all those who are involved.
Chris Choi and Nick Young here at the CSU Natural Resource Ecology Lab, Colorado State Forest Service with Amanda West Fordham, Ethan Buchholz, and Maria Gattani. Olaf Kugler at the Pacific Northwest Research Station of the USDA Forest Service. The FIA program in the Rocky Mountain Research Station region, Kristen Pells, Aaron Berryman, Kyle Dodson, Karen Kralachek, Nadia Tace at CAL FIRE, Glenn Christensen at the Pacific Northwest Research Station, Kurt Mackis, James Lucero, Tim Reeder at the Colorado State Forest Service, Jeremy Groom with Groom Analytics.
And thank you to Ashley and Tony for taking the time to share your knowledge with us.
Thank you so much for having us.
Yes, thank you, Field, for having us. It's been a lot of fun.
And be sure to keep an eye out for the release of the Carbon Accounting Framework coming soon.
Thanks for joining us on this episode of Forest FM. To learn more about the podcast and the Colorado State Forest Service, please visit our website at csfs.colostate.edu. Take care, and we'll catch you next time.